So you may remember another proof of this could be carried out by cases, and that was a little bit tedious because then you'd have to consider all numbers that are multiples of 5, one more than a multiple of 5, etc., etc. So at least with this one, we have a chance to try induction, and let's just see what plays out here. So naturally, this is a claim for all natural numbers that are positive integers, also all natural numbers. I was a little redundant there. So we'll establish a base case, which means n equals 1. And we have n to the 5th minus n would be 1 to the 5th minus 1, which would be 0, which is a multiple of anything, so we'll take it as a multiple of 5. Okay? So now we'll assume that k to the 5th minus k is equal to, now I want to show that it's a multiple of 5, so I'm going to say this is equal to 5m for some k. So we want to show is that when we move up to the next integer, the k plus 1, that this follows to be a multiple of 5. So k plus 1 to the 5th minus k plus 1 is equal to, now, I need to get that k to the 5th minus k worked into that expression somehow, because that is understood already to be a multiple of 5. So we are going to have to multiply out k plus 1 to the 5th. Well, turns out after you go through, or if you know binomial theorem already, you can use that too. That is going to be k to the 5th plus 5k to the 4th plus 10k to the 3rd plus 10k to the 2nd, plus 5k plus 1, and then minus k minus 1. Okay, so at this point, what do we have? So we know that k to the 5th minus k is a multiple of 5. So we can replace that with 5m plus 5k to the 4th plus 10k to the 3rd plus 10k squared plus 5k, and these 1's cancel out. And as you can quickly see, this is a multiple of 5. So just write this out here, factor it correctly. And we know right now that this is a multiple of 5. So that proves the statement. We've shown that, it's true for n equals 1, which means by using that logic, it'd be true for n equals 2. And you can check that. 2 to the 5th is 32, minus 2 is 30. So we have a multiple of 5 there, and then it follows that all the rest of the integers produce multiples of 5. So there we have it.